So I have just made one one PDF kind of thing where all the NFPA 13 and 14, everything is at one place. Like all
Summary sheet.
summary, it is kind of summary sheet. So
Yes.
it's a very useful data. First, I have written something about the standpipe, like what is class 1 system, where it should be actually I got one document. So I have just taken from that document and I found this very beautiful actually. So everything, all the important points from NFPA 13 and 14 is written in this 28 pages. So you can go through this. Class 1 system, what is class 1 system, what is class 2 system, class 3 system, standpipe number and connections, where you have to give the standpipes, and where 2 or more standpipes are installed, they shall be interconnected at the bottom. Where standpipes are supplied by tanks located, they also shall be interconnected at the top. In such cases, check valves shall be installed at the base of each standpipe to prevent circulation. Here they are focusing for the check valve. We have to use the check valve whenever we are talking about this standpipe system. And next,
sir, just one question. Is there any codal requirement to have installed check valve instead of butterfly, instead of control valve at the base of the riser? The base of the standpipe.
The check valve, butterfly valve, actually we have to go with everything. Check valve and butterfly valve. Because butterfly valve is also important. Check valve is only used to restrict, like if you don't want the water to flow back, then we have to go with the check valve. Otherwise, butterfly valve we have to use to regulate the flow. Both the things are required actually. Pipe sizing, pipe can be sized by hydraulic calculation according to pipe schedule. Class 1 and class 3 shall be at least 4 inches in size. Standpipes that are part of combined system shall be at least 6 inches. This one,
sir.
NFPA 14.
Just one second. No, what I'm talking about, is there any codal requirement? Because we can install in no issues, but just to ensure, is there any codal requirements in India?
Here only they have given, in NFPA 14 only they have given. Whenever you are having any wherever we are having 2 or more standpipes, they shall be interconnected, and how you are interconnecting with the use of check valves. So this particular code is enough, I think so. This is NFPA 14 only. This, all the points what you are saying is written in NFPA 14 only. So I have just taken some picked some few important points, and here I have written. Then here also pipe sizing also they have given. What should be the minimum, what should be the combined system, and what is the flow rate. This thing, yes, in the last class we have seen. What is the flow GPM? 250 GPM will be for each standpipe. So that point only it is written. Total system required discharge not to exceed 1250 GPM. So this point also we have seen. Like when the building is like sprinkler and hydrant, both the systems are there, then you have to go 1250 GPM only. Pressure, what is the minimum residual pressure at the outlet of 100 PSI? Minimum residual pressure at the outlet of 1.5 inches, 65 PSI. We have seen the pressure ranges 65 PSI, 100 PSI, 175 PSI. So that point is also written here. Some exception points are written here. It is not required actually. Then the ranges are also written. Residual pressure range for 2.5 inches, 100 to 175. For 1.5, 65 to 100 PSI. Okay. And where the static pressure exceed the pressure, an approved pressure regulating device. So this point will give us the pressure regulating device. Okay. Use of pressure regulating device. Class 1 and 3 system, NFPA 14, hydraulic calculation procedure. Each hose connection required 250 GPM. Use 2 connection at the most. Use 1 connection at each additional standpipe. Total flow not to exceed. Some things are given here. So everything is same only. So just they have written some points. Again, the same points they have written. You can go through that. This is something about the NFPA 14. Then in NFPA 13 also you see the type of sprinklers. Firefighting systems are given here. So you can go through that. Okay. 1 minute. According to the actuation system, wet pipe, deluge sprinkler pre-action. We have discussed this according to the like dry pipe, combined dry pipe, according to the system shape, pre-sprinkler, gridded loop sprinkler. Okay. Classification of occupancy hazards. Now this table is a little bit good actually. Why means because here they have given everything, like what will be the area of minimum area of operation, what will be the density for light hazard, ordinary hazard, and extra hazard. Everything is given here. Okay. In the same way, there is one more table here given for hose discharge requirement. Now this is also one important parameter, like what will be the inside hose value, what is the total combined inside and outside hose GPM. So this value you will get to know when we see the allied calculation. Here the references are also written from where we have taken the this particular table. The minimum pressure, sprinkler residual pressure, light hazard, ordinary hazard. This is for the pipe scheduled sprinkler. Okay. Just a minute.
Mr. Atif,
Yeah.
For the GPM calculation for the full system of the firefighting system. Suppose we have outdoor hydrant, indoor hydrant hose reels and sprinklers, and ordinary hazard. It will be 100 GPM for the indoor, and assume 2 working for outdoor, I think, 300 GPM and 500 for the sprinkler. Like that, the total GPM will calculate it?
No, that procedure is entirely different. We will see that later we will see. Here they have given one point I like about this is they have given about the sprinkler characteristic. Some points are written about the sprinkler. So this point also you can see, this is also the additional information. Again, this thing is also taken from NFPA 13 only. And here the characteristics are written, sprinkler, like thermal sensitivity is one characteristic, temperature rating is second characteristic, orifice size is the third characteristic, installation orientation, etc. etc. Some points are written here. System protection area. This everything we have already seen. Okay. System requirements. Now you were asking about here only they have given every system separated zone control valve and all should have these things. Swing check, pressure, test and drain assembly, air vent. Okay. So these things are given. So just you can go through this book also. Some points are written. Now I will directly come to the this thing. Okay. The hydraulic calculation procedure. Now first try to understand like what is the hydraulic calculation and why we are doing the hydraulic calculation. The reason why we are doing hydraulic calculation is because we have to calculate the flow and pressure. Okay. See, the good thing about the firefighting is that minimum pressure we requirement for the system we already know, which is 7 psi. Okay, this thing is not applicable in HVAC or plumbing. In HVAC or plumbing, we don't bother about the residual pressures. We just do calculation and we go according to that. But in firefighting, we have to like we already know what is the minimum operating pressure we require. So based on that minimum pressure, we will pull out the maximum pressure. And even the maximum pressure range is also given in firefighting, like 175 psi. So 175 psi is the maximum pressure range given, and 7 psi is the minimum pressure given for any system. Okay. So obviously we already know that our pressure will come in between this value only. Suppose if anyone is doing high-rise building and is getting the pressure beyond 175, then obviously they have to limit the pressure to 175 psi only. So here, whenever we are doing the hydraulic calculation, first I will show you some steps what we have to do, and the manual method first we will see. Okay, because this manual method is not applicable actually, but still if you want to apply this hydraulic calculation manual method.
No one will accept any authority. The manual calculation should be software.
Yes, but I'll just show you.
Yeah, we need to learn it as well. Yeah, of course.
Yeah, just for your knowledge purpose, you can see that. So normally what happens, Okay, finally it happened. So the very first step whenever you are doing any hydraulic calculation is we have to determine which building, which type of hazard we are doing, like ordinary or extra hazard. So this will be obviously our first step. Once we get the first step, the second step we have to get the density from density area curve. So we have seen the density area curve also, like for light hazard it is 0.1 GPM per square feet. Okay, and for ordinary hazard I think it is 0.15 GPM per square feet. Now, what is the use of this density area curve means?
Sir, just sorry, one second. Can't we use SI units because GPM is critical?
It is given assignments, you have to go with mm per minute.
Per minute square, yes.
Minute. Actually, that is not even I'm not used to that, because this is the easiest way to write down actually GPM per square feet, because this is given in NFP only, this value. That minute also they have given, but actually will get little bit confusing. Now, what is the use of this density area curve means? Simply what you can do, you can calculate just based on this one value, you can calculate the flow requirement. For example, if my area is 1500 square feet, okay, if the value is 1500 square feet and density by area or the density area curve is 0.1 GPM per square feet, so I can easily calculate my water requirement. What I have to do, just simply I have to multiply this area into 1 and 2. I need to multiply 1 into 2. So 1500 square feet into 0.1 GPM per square feet. So my square feet value will get cancelled and this will become 150 GPM. So this is one of the advantage of using this density. Just if you know the area, you will at least know what is the GPM value you are going to get. But
for the sprinklers now. Yeah.
Yes, but this is not the right procedure. Just I am showing you one example. This is the one of the advantages. Obviously, we have to get the density area. Next thing, we have to determine the K factor. Like, obviously, we are taking 5.65 only K factor, because NFPA 13 also said that if you don't know any K factor, just go for this K factor only, 5.65. This is the most important.
But sir, in critical area, that may be changed. Like
that will be changed.
Prior
that will be changed. 8, 11.5. So many different K factors are given.
Because of the pipe, with the changes of the pipes. If you see,
this is the standard value actually, 65.5. Now this formula is the, this is only the density area method. What we were discussing in the last class. Like just let me open this file, that firefighting standard book NFPA. I think here only it is given. I think some page number 230. You should remember the table, chapter number. In this chapter only it is given somewhere, hydraulic calculation procedure. I think little bit up it is given. The density area method is given somewhere here only. So from there only I have taken that formula actually. So I wanted to show you, because the same thing you can like explain to client also. See, this is the density area, where the density area is designed based on the design area shall be rectangular area. So here I have considered this A as the rectangular area, having dimension parallel to the branch line at least 1.2 times. I have taken 1.2 times of the area and times the square root of the area of the sprinkler operation. So just instead of square root, I have written 0.5, because if you convert this square root, it will become 0.5 only. So this is the formula I am going to use for the manual calculation. Now you should know this calculation is also helpful for you. You can explain to client also. Suppose some clients are not going for Elite software. They want to go with the manual calculation also. So you can after getting thorough results from this calculation, you can explain to client why this manual method is not suitable, why allied software is suitable. So that thing you can explain. So this is the formula we are going to use for our hydraulic calculation. Once we calculate this, then next step we have to find the number of sprinklers. Okay, like design area by length of design area. Then go for the longest run, most remote point to get the calculation. Find the GPM and sprinkler. The formula is shown here. Q is equals to this area into density. Something is written here. P is equals to Q by K whole square. From where we got this formula means this is the K factor formula. K factor formula, if you remember the K factor formula, this is the K factor formula. From here I have written this. So first what I am doing means I am going to find Q value. Next I am going to find P value. I have to make one table. Now here we have to make one table in hydraulic calculation. This is the most important table actually. We have to make this table, because if you make this table, like suppose you are doing for 100 pipes, 100 pipe sections. So if you make this table perfectly, 100% perfectly, then your work will be, obviously it will be reduced workload, because you have to always check what is the node, what is the diameter, which fitting you are using, length, total length. So a lot of things you have to check. So it's better to make this kind of Excels. In Excel you have to make like, I will show you. I will be using this particular Excel sheet. See, this is my Excel sheet. So this Excel sheet is like whenever we are doing the allied software. This Excel sheet, whenever we are doing the manual hydraulic calculation. So this Excel sheet you have to always make properly. And if possible, if you can get a printout and you can do work, that will be more effective, because we have to put these values only in our calculations. Next, Hazen-Williams formula will come into action, because we have seen that we have to use the Hazen-Williams formula whenever we are doing any manual pipe hydraulic calculation. So Hazen-Williams calculation will calculate the friction losses. It will be used for friction losses. The most important is the node 1 calculation. Okay. You have to create nodes like node 1, 2, 3, 4, 5, 6, like that you will be making nodes. So the critical point will be the node 1. And in the node 1 calculation only, you have to get the 7 PSI. If you fail to get that 7 PSI in node 1, then your whole calculation is wrong. You have to change certain values, or you have to like rework on your calculation. This is this case only in your manual calculation. It will not happen in the allied software, because allied software will clearly ask you what is the minimum residual value you want to put. So we will write 7. So obviously our calculation will go more than 7 only. But in manual calculation,
what is node 1 calculation? Is that the
what is
I'll show you. I'll tell you. I will tell you. Just I am showing you the steps actually. These are the steps. Once you calculate node 1, then we have to go for the node 1 to 2, and this is the procedure. P2, we have to calculate the value pressure 2, because see, whenever we are doing the calculations, it will be something like this. Suppose this is your pipe. Okay. And in these pipes, your sprinklers are attached. One sprinkler here. Just I am showing you randomly. Now, how you are going to define the nodes means you have to follow the maximum. Okay, you have to follow the header pipe, or the one pipe to which all the sprinklers are attached. Like for example, in this case, this is my main pipe, and I want to include all the sprinklers means, then what I have to do? I have to start writing the node number 1, 2, 3, 4. I will write 5 here, 6, 7, 8, 9. This new actually feature is very confusing. 10. This is 10. This is 11, 12, 13, 14, 15, and 16. Just imagine I have written here 16 nodes, but in real projects, you will get 30 nodes, 40 nodes, 100 nodes. You can go up to 1000 nodes like this. Our Allied software will go up to 1000 nodes. So here what I have done, simply I have added these 6 sprinklers in my network of pipe. Now I have to start doing the calculation from this point. First I will calculate for this point, then I will calculate for this particular pipe section 1 to 2 node. So here that thing only I have written. First node 1 calculation we have to calculate Q1 P1, then node 1 to 2. Whenever we are following node 1 to 2, we have to calculate pressure number 2. Means pressure number 2. At this point, what is this I have to calculate. P2 is equals to P1 plus PF of 1 of 2. And these formulas are also given in some NFPA book only. So I think that also I will show you because I have seen somewhere this formula is written there actually. Now here you have to extract this PF 1 of 2 is nothing but total length into Hazen-Williams formula. Total length you will get from this particular table, and Hazen-Williams formula you will get from here, 4.52 into Q1C by D1. Once you calculate this P2, next you have to go for this Q2. Q2 is equals to Q1 into square root of P2 by P1, and you will get P1, Q2 and Q2. In the same pattern, you have to calculate at each and every point. At this point, at this point, at this point, each and every point, you have to calculate two things, pressure and flow, pressure and flow. So once you come to the last point, so that will be your maximum pressure and maximum flow. This will be your minimum pressure and minimum flow. This will be your maximum pressure and maximum flow. So here also I have written the same thing. Follow the same steps for all nodes like 2 to 3, 3 to 4, whatever the nodes. So this is the step number 7. Okay, we are just trying to understand the hydraulic calculation step. After step number 7, these things are just, I don't think these are very reasonable steps, but still I have written here. You have to calculate static pressure, building height by 10.28, calculate relief valve, NFP 20 to find diameter of suction discharge. Some steps you have to calculate the relief valve, check valve, means pressure you have to add some factor of safety. Here you have to add some factor of safety. Whatever the pressure you are getting here or flow here, you have to add some factor of safety. Find the overall Q and P for all pump, add all Q values, add all pressure values, get the volume of pump, get the volume of size of water tank. Volume you have to check. So these are the steps. After that we will go. Okay.
Boss, T, is it the time to discharge or time to fill the tank?
Yeah, time to discharge actually.
And what is the 0.2 factor?
That is the
factor.
To convert GPM to cubic meter.
Okay.
This is a very basic things actually, but when we do the Allied calculation, so in Allied calculation, wait, I will show you the Allied report.
But, boss, this is the volume. This is volume of the water inside the firefighting tank. We need to increase it by for air gap 30 cm, right?
See, this calculation only for Q and P values. Nothing we have to add anything other than that. See, when you open the Allied report, in the Allied report, everything will be done systematically. And here they will give you the water requirement also. Like the sprinkler, see here, the pipe system water volume will be given 148 gallon. Now, if I convert the gallon into cubic meter, okay, if I want to convert gallon into cubic meter, I can convert that value also, because here they have already given. So that with that way we can get the tank capacity.
Suppose this gallon is Imperial or UK or USA? This gallon Imperial?
Gallon, yes, I think so. Gallon in Imperial, liter in SI units, I think so. This gallon is in US Imperial, yes. So that I will explain you later, like how you can convert with this value. We can check.
I know to convert, but I'm just to make.
Okay. So here what you have to do means, now this is the steps. I will show you one example also. Just follow this example and you will understand easily how to do the calculation. Don't need to bother much about in this calculations. Suppose I have taken one area, just randomly I am taking one area 20 by 10 meter building. Okay, it is 200 square meter. Let us assume this is light hazard area. And here the same density area curve I have drawn from NFPA 13. And here I have taken the minimum area of sprinkler operation from NFPA 13 only. How to do the calculation? See, first here I am trying to do the calculation for number of sprinklers. First, I will use this formula. L is equals to 1.2 area 0.5. Now this formula says that this area is your sprinkler operation area. So the area of sprinkler operation is 200 square meter. So just I have multiplied 1.2 with 200 into 0.5. I will get 16.97 square meter. Why? Means because my SI unit is in square meter. So this value will also will get in square meter. How to find the number of sprinkler? Just divide the design area by the length of design area. So you have to divide 200 by 16.97. You will get 12 sprinklers. This is one of the method given in NFPA 13. This formula, this density area method. There is one more method given in NFPA 13 only, where what you have to do, here what you have to do, just convert the area in square feet, get the density, water demand for sprinkler, multiply this to area into density, you will get 215.2 GPM. Area coverage for one sprinkler is 20 square meter. And we have area as 200 square meter, just divide that by 20. You will get 10 number of sprinklers. So here what I have tried to done, first here I try to get the water demand, which is 215 GPM. And here I try to get the number of sprinkler. Simply what I have done, area I have divided by the maximum protection area, 20 square meter or 225 square feet. If you divide this 2152 by 225, you will get the same result, 10 sprinkler. So for understanding purpose, I have created one sheet here also. So this sheet will be my reference sheet for all the sprinkler selection. Like here, what I will do whenever I will do any project. So I will first write down the floor. Okay, whatever the floor, I will write down the description of area, like description. Here I will write down the square feet area. I will convert it into square meter. Sprinkler selection as per hazard. Simply I will divide square feet by 225 square feet, because the maximum protection area for light hazard is 225 square feet. If you are doing for ordinary hazard, just change this value to 130. So like that, I will get certain number of sprinklers here. If I know exactly in which area, in which place I am keeping the sprinkler, I will get the number of sprinkler. Next, what I will do, I will compare this result with the density area method, which is what 1.2 into area of sprinkler operation to the power of 0.5. So here what I have done, simply I have taken area in square meter. I got the density area of method. Then sprinkler selection as per density area method. The formula is simple. 84.6 divided by 11. D5 divided by F5, you will get this number of sprinkler. Again, the same thing follows. Here I will get the 82 number of sprinkler. Just see the difference between these two methods. One method is telling 36 number of sprinkler. Even this method is also approved in NFPA. And this is the density area method. It is telling 82. To avoid confusion, what I have done, actual number of sprinklers selected depend upon the project requirement. Suppose a client wants 50 sprinklers. They want, because a client will be always selective or calculative in terms of like cost cutting or money, like they will always think about the budget only. So what I have done, simply I have written here, actual number of sprinklers selected depend upon the project requirement. So here you can see the variations. Sometimes we are getting 3, here we are getting 6, here we are getting number of sprinkler 1, here we are getting number of sprinklers 5. So like that, some variations are given. So that's why I will tell that the method, the table, what they have given, the maximum protection area is not always right. You have to cross check also. And the best way to cross check is go to the real-time project and check the real-time condition and place the sprinkler according to that only. Otherwise, what happens? Just see this room only. This particular room, as per this hazard, it is telling that only one sprinkler is more than enough. But here we are getting 5 number of sprinkler. So that is the difference. So that's why you have to always first place the number of sprinklers only. Before doing any hydraulic calculation, first place the sprinklers, and placement of sprinkler will be done based on your analysis. Okay, no one is going to teach how to place the sprinklers, because that is something which is common understanding actually. So you have to understand how you are going to place the sprinklers. Based on that, you have to check. So this sheet, I have just created this sheet. Whatever the number of rooms, you can add it, just drag it. Whatever the formulas are written, you can get the results in a very quick time. Just you need to know what is the area in square feet, what is the just one thing is required, either the area in square feet or the area in square meter. You can just make this sheet in no time. It will not take much time if you have a proper area sheet. After that, what thing is given here? Now, this is one example I have shown you, both the methods, like what will be the effect if you are following density area method, what will be the effect if you are following the maximum protection area. Okay. Next here, we will do the real manual calculation method. Okay. Like here, I have taken the 1500 square feet because as per NFPA, for light hazard, the minimum protection, the minimum design area we have to take is 1500 square feet. So I have taken 1500 square feet here. And simply what I have done, number of sprinkler I have selected 1500 divided by 225. I am getting 7 sprinklers. Then just for our understanding purpose, I have written this point. Okay. It nothing has to do with our calculation, just to remind you that we have to not only reliable on this 7 sprinkler, but also we have to check these points also. Because if you forget about this point and you are relying only on this 7 sprinkler, means just imagine what will happen if you design the entire project. You have designed the 100 rooms, you might be doing some mistake, because even we also do sometimes mistakes. So that's why you have to check both the criterias, the maximum protection area and the distance between 2 sprinklers and sprinkler and wall. So I have just written, and I have shown here one very basic thing. Like I have placed 3 sprinkler here, 3 sprinkler here, 1 sprinkler here, and I have written just we cannot select 7 sprinkler because it is violating NFPA 13. If the same thing you are using with this method, you are getting 10 number of sprinkler. See the difference. I am taking the same area and dividing by 225, I am getting 7 sprinkler. Same sprinkler, same area I am taking, and I am dividing by this density area method, I am getting 10 sprinklers. So this is the difference. Then what I have done, just I have kept it 5 sprinklers on the top, 5 sprinklers on the bottom, and I have checked the distance between the 2 sprinklers protected as per NFPA 13. I have created one network. Okay, like the sprinklers are placed. And remember one more thing, like it's up to you how you want to work, but I always prefer to go something like this. Suppose if I'm placing one sprinkler here, I will take a gap. I will take some distance and place here. Because what happens, if you want to place like this also you can place, but here you have to use one 4-way. There is a fitting, 4-way fitting. So even though 4-way fittings are also fine and 3-way fittings are also fine, but just imagine if you are using more 4-way fittings, because everywhere you are just attaching like this. So there may be chances that there is a loss of pressure, or some places if the pressure is good, and you can go with the 4-way or cross fitting also. But I think it will affect our elite calculation. Sometime what happens, we cannot get the proper results. So that's why I usually avoid this kind of situations actually, 4-way. So it's better to go with only 3 ways. If you're going with 3-way, you can get the proper notes. Like I will give 1, 2, 3, 4, 5, 6, 7, 8. Now, if I'm doing the allied calculation like this, it will be very helpful actually. So I can easily get the pressure at each and every pipe section. Like I can get the pipe pressure here at this point, at this point. So each and every point I can get the pressure easily. So like that I have created here, and I have just written 1, 2, 3, 4, 5, 6, 7, 8, 9. See here I have not added all the sprinklers just to to minimize the calculations. I have written only this 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we are doing in the allied calculation, you have to write at each and every point. Whatever the sprinklers you want to add, you have to write that. Okay. Yeah. See here. After that, I have just created this one. Once you created the network of pipe, the next work, what we have to do is we have to write down the pipe sizes. This is the next step. See, the very first step in hydraulic calculation are those 12 steps, whatever the written. Next, you have to calculate the sprinklers. You have to place the sprinklers. You have to check whether the placement of sprinklers are violating the NFPA rule or not. Once everything is perfectly done, then go for the pipe sizing. How to go for the pipe sizing? Again, it is written here only. The pipe size is also given here. Somewhere is given. This is the problem. You have to remember the points. That's why what I will do, just I will open that particular file. I think somewhere is given. Just a minute. In this file, I think I will get, see here, pipe size. So here they have written the pipe sizing actually. For 25 will be 1 inch for the 2 sprinklers. Now just try to understand with this example. I hope you will understand very easily. Suppose here I have connected the number of sprinklers. 1 sprinkler, 2 sprinklers, 3 sprinklers. Then here also the same way, 1 sprinkler, 2 sprinkler, 3 sprinkler. Here 1 sprinkler, here 1 sprinkler. Okay, like that I have like place the sprinklers. Now I want to start from the, now I want to start the what you can say. First I need to give the notes 1, 2, 3, 4, 5, 6. This is the 7, 8, 9, 10, etc. Okay. Now I need to first identify what is my main pipe. Okay, which is the main pipe? This is the main pipe. To this pipe only all the sprinklers are connected. Okay, this is my main pipe which is going towards the pump side. This is the pump, and to this pump this is the network of pipe, and these are the sprinklers connected. Now what I will do, I will start from this point. Okay, either I can start from this point or this point. Don't start from in between. So I want to check the pipe sizing now. How I can write down the pipe size? Just see here. As per this point, for 2 sprinklers, I can go with 1 inches.
1 inch.
So here will be my 1 inches. 1 minute. Just let me delete these things. It is confusing actually. So this will be my 1 inch. This pipe will also will be my 1 inch. And this pipe, which is connected with the main pipe sprinkler, this will be also my 1 inches. Why means because as per the NFPA 13, I can connect for 2 sprinklers 1 inches. Now this pipe, to this pipe section 2 sprinklers are connected. So I can go with 1 inches. Even this pipe also 1 inches. Now this pipe.
40 mm should be 1 inch and yeah.
3 sprinklers are connected to this pipe. So I will go with 1/4 inches. This is my 1/4 inches. This will be also 1/4 inches. The same thing will follow here also. 1 inch. This is also 1 inch. This is also 1 inch. This is also 1 inch. This is 1/4. Now, when you are going for this pipe section, 6 sprinklers are connected. 1, 2, 3, 4, 5, 6. You need to check for 6 sprinklers. Like here, they have given 1.5 inch.
40 mm.
I will go with 40 mm, 1.5 inches. Then again, this is 1 inches. This is also 1 inches. All the singular are 1 inches. Now I need to check this particular sprinkler. So this particular pipe section, 7 sprinklers are connected. So
50 mm, 2 inch.
I can take 1.5 also because it is 7 sprinkler only. So here I will take 1.5 inches. But from next pipe section, I will go with 2 inches. Like from this pipe section, I will go with 2 inches up to 10 sprinklers. So this will be also my 2 inches because 1, 2, 3, 4, 5, 6, 7, 8, 9. Even this one also I can take 2 inches because 10 sprinklers are coming here. But here 11th sprinkler is adding here. So for 11th sprinkler also I can take 2 inches because up to 30 sprinklers I can go 2.5 inches. So I can keep this also 2 inches. This also I can keep 2 inches. For safer side, what I will do, this side I will take 2.5 inches. Maybe in future if any additional sprinklers are adding. So like that we have to go for the pipe sizing. Okay.
Hello, sir. One more question. What will be the sizes if I go with more than 5.6 K factor, like K60?
See, 5.65 is just the K factor. It nothing to do with the pipe sizing. This is the manufacturer side actually. This is the headache of manufacturer side. We don't have to bother about this thing, but definitely if you are taking this K factor, I think pressure and flow value will change. So whenever we are selecting, so suppose in this way also I have written here the same pipe sizing. After that, what I will do, I will create the nodes like node number 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. And here I will write down the diameter fitting. How to write the fittings means, just understand that whenever we are coming near the sprinkler, we have to add one elbow. Okay. And here you just observe, I have written reducer and T also. So remember that there is no fitting called as reducer in Allied software, because in Allied software, we will not get any option for reducer. Either we will get T or cross. So we have to select any one, either T or cross in Allied software. So that's why I have written here T. And T is nothing but wherever the pipe size is changing. Like if you are getting any pipe size like this, so here we are using one T. So that we will see this fittings and all in our Allied calculation class. Length is length. You have to just add the length. Whatever the length is adding up, you have to add the length, and equivalent fitting length you have to take from here. This is the equivalent length fitting table, which is already given here. So
for the valves and for the elbows and for mechanical
everything,
as well.
Yeah, everything is given here. So I will just skip this part for now, because when we go for the Allied calculation, I will explain in detail. You have to add length plus fitting length and C factor. Suppose you have added everything. Now we have to start doing the calculation. Just observe how to do the first calculation. Q1 AD into density. What is the AD? Length of design area. Let us come back to the example once again. In our example, we calculated this formula, this value, 14.34 square meter. Okay, so this value I am going to multiply here, 14.34. But this value is given in square meter, so I am going to convert this into square feet. 14.34 into 10.76 into density 0.1 GPM per square feet. So I got the value as 15.42 GPM. Then I am going to calculate P1 as Q1 divided by K whole square, where K factor is 5.65. So my P value I got as 7.32. Now I got the value at this point greater than 7 psi, then I can say that I can go ahead with the calculation, because this value I should get always greater than 7 psi only. Calculated Q1 P1. Next, I will go for the node 1 to 2. Whenever I am doing the node 1 to 2, I will write P2 is equals to P1 plus PF1 of 2. So P1 we already calculated 7.32. Next, I need to calculate PF1 of 2. How to calculate PF1 of 2? Length equivalent into Hazen-Williams formula. Length equivalent already we have calculated here for each and every node. Only thing which we have to calculate is the Hazen-Williams formula. And this is the formula, 4.52 into Q divided by C into diameter. Q, we have to take the Q1 value, 15.42. C is always 120. And diameter, we already found out what is the diameter here, 1 inches. If you multiply each and everything, you will get this value, 0.101. Remember the SI unit, PSI per feet. Then add the length of equivalent. Then multiply length equivalent with the this Hazen-Williams formula. You will get PSI value, 0.801. Just add P1 with this PF1 of 2. You will get P2 value as 8.128. Then this is the formula to calculate Q2. Q1 into square root of P2 by P1. You will get 16.24. This is my Q2 P2. Observe that the Q1 P1 value will be lesser. Q2 P2 value will be higher. In the same way, everything will follow. If you go to the node 2 to 3, next you have to take the consecutive value. Like previously we have taken P1 value here. Now we will take P2 value here. And here also we will take PF2 to 3. Same pattern you have to do the calculation. And you will get P3 value, Q3 value. Remember, you will observe that Q3 and P3 value are going on a higher side. So I will just skip to this calculation part, because you can go through this very accurately if you have any chance to do this calculation. I have just taken the consecutive values. Previous values I have taken. Finally, my last one was the P8 Q8. I got this value. Once I got, this value is something near. Where is this? At this point. Okay, at this point, I got this value. Next at node number 9, I have just taken the 50% extra value. Okay, factor of safety.
Safety.
Yeah, factor of safety. So I got Q9 as 27.9. Next, what I will do, I will calculate the head value. Okay, this is also again the manual method. Don't bother about this calculation. So first what I will do, residual, whatever the pressure residual value is given, 10.75 psi, I will multiply with some factor to convert it into bar actually. Actually, this is the formula given here. 10.75 into 0.06895, something will become 0.741 into 10, it will become meter, 7.41 meter. Then building height, P static, what I will do, building height divided by 10.28. If you know what is the building height, just multiply with 10.28, you will get some value. Next, fittings, residual plus static into 15% I will add here. So 8.38 into 1.15, you will get some value, 18.18. Just add 20% factor of safety, you will get some head value, PSI bar. Then volume of tank. So these things, you can skip this thing, but up to this point, it is okay. But remember that whenever we are doing the hydraulic calculation, manual hydraulic calculation, only you can perform hydraulic calculation if the nodes are very less, like 10 or 12 nodes. If it is given, then only you perform. Otherwise, you don't need to perform that calculations. Okay. Now, just remember this thing. Whenever if anyone is asking you the manual calculation, you can produce this result. But anyhow, in our next classes, we will see the allied calculation. Okay. Before starting the allied calculation, okay, so I will quickly take 15-20 minutes to explain NBC. Okay, only not much time I will take. Some 15-20 minutes only I will take. Some table is given in NBC. So quickly we will go and we will start the allied calculation. So
today elite calculation today or tomorrow?
I think yeah, that I need to like today it is not possible.
Boss, tomorrow please, because really we are fulfilled from relaxed here.
Yeah. That let us see.
The remaining time for the lecture, is it for MBC code or you will still have something to show us?
No. In this class only, like whenever we start the Elite software only, then only we will see the NBC. I will show you how to download Elite software. See, when we get the Elite software, you will get something like this. See, this particular folder you will get Fire 6. So in this Fire 6, the most important is the license file, Fire W. So just say this. Okay, whenever you are installing the Elite software, all files should come here, and this Fire W is the license file. Once you get this file, you have to just double click it. If you double click it, the license file is successfully copied. Once it is copied, then you can open this the above Fire W. This is the software, and here it should be written 1000 pipes. Okay, if it is not written 1000 pipe means something is like not good. You have to change the calculation, change the file actually. If you go in the enter or edit pipe data, here it should be written 1000 pipes, because 1000 pipes are very what you can say, it is very much actually. Just imagine 1000 pipe means up to 999 nodes you can do calculation, starting from 1 to 2, node number 1 to 2, up to 999 nodes you can do. And I think I don't know whether anyone has done that calculation or not, but it is more than enough, because there are so many like nodes are given here. So this thing we will see later. Like tomorrow, what we will do tomorrow, we will start start with the Elite tomorrow only, no issues. So tomorrow what I will do, I will just take one example, and I will prepare some previously at least I will show you tomorrow one worked example. Okay, the one which I have already worked. So that example I will try to input in the software, because I think it will take a lot of time for us if I don't do any previous I will complete my half work, and then I will explain you. Then we will try to input the values. The same way you can also follow for different example, so that it will be easy. Because if I start filling all the values in class, for 40 nodes or 50 nodes, so it will take a lot of time. So we will try to uh, avoid some time, and half work I will previously, before the class only I will do half work, and then I will explain you in that pattern. We will see, and we will sit, no issues. We will sit at the same time, 9:30 p.m., and we will look for the Elite software only. Okay, and for that relax class we will shift little bit earlier, 8 p.m. to 9:30 p.m. we can shift, not an issue. 10-15 minutes if it is going above and below, just bear with that particular time if it is going 10-15 minutes. Otherwise we will start it, because uh, from Wednesday onwards I think Diwali is starting here. So my plan is to complete up to Wednesday. My plan is to complete this Elite software. So we have to go quickly, we have to act quickly. So because once this Elite software is done means a very major portion of firefighting will be completed. So that is the target actually. So we will focus on this Elite software in the next 2-3 days, and we will try to complete this in next 2-3 days only. I will share you the link. Okay, with the mail I will share you the link, and remember that you have to download from this Fire 6 only. Just Fire 6, download everything. If license file is not copied, don't worry. I will show you how to download this Fire W. Sometimes what happens, because of the antivirus or because of some internet activities, the license file will not get downloaded or installed or copied in your system. So don't worry about that thing. Just keep it ready before the class, and next class we will meet. We will start directly our Elite calculation. Okay then. So I will stop here only. Thank you.